oops, let me go back. So on question 7 here, we're going to talk about the intelligent quotient, or IQ, scores normal distribution with a mean of 100 and a standard deviation of 15. Let me get my black pen back here. If individuals between 90 and 110 are classified as average, what proportion of the population is average? So we need to do our z-scores. So starting off with 90, this is going to be 90 minus 100, which is our mean, divided by our standard deviation, which is 15. So this would be negative 10 over 15, which would reduce down to a negative 0.67. Again, making sure to round to 2 decimal places. We're going to do the same thing with the 110. So 110 minus the mean of 100 divided by the standard deviation of 15. So this is going to be a positive 10 over 15, which is going to reduce down to a 0.67. So since these are the same number, just different signs, so one's negative, one positive, we can use that one row of 0.67, and then what we're going to do is we're going to look at that last column. But remember, what we're going to have to do is take that value and we're going to have to double it. So we're going to take the 0.2486, multiply that times 2, and we get 0.4972, or the second answer. Anytime we want something between two values and our z-scores come out to be the same but with different signs, one positive, one negative, then we're going to use that last column D to be able to figure out what that is, and we always have to double that value, whatever it happens to be. Okay, so what z-score represents the highest 25% of our distribution? So when we're talking about the highest 25%, we're going to be looking at the column C here, because that's the greater than part of our column. And since we're looking at 25%, that's definitely smaller. Remember, your 50% mark is here, 50% above, 50% below. So if we're looking for 25% above, it's going to be that last, or that middle column C. So what we're going to do here is we're going to look for as close to 25 as we can, and that would be one of these guys right here. So to figure out if it's going to be the 25.2514 or 24.83, we're going to come over here and we're going to go 0.2514, oops, minus 0.2500, and that is going to give us 0.0014. And then we're going to see the same thing for the other one. We're going to put the 0.25 first because he's bigger, so 0.2500 minus 0.2483. And when we do that subtraction, we get 0.0017. Since this is smaller than this one, we're going to use that particular one as our 25%. So we would say that the z-score here would be a positive 0.67. And if we had said the lowest 25% instead of saying the highest, if we had said we wanted the lowest 25%, then this would have been a negative 0.67, since it would have been on the small side of that. Okay, so now we want the highest 60%. So again, think about this. This right here is 50% of my data. So the highest 60% would be over here in my negative z's. That would be my 60%. So that means I'm looking at my z-score here, and I want to look at column B and try to get as close to 0.60. Remember, 60% is 0.6000. I want to get as close to that as possible. So if I look here, it looks like one of these two right here is going to be my closest I can get. So starting off with that first one, I've got 0.600 minus 0.5987. So if we do that math, 0.6 minus 0.5987, we're going to get 0.0013. Now do the other one, and I'm going to put the one on here first, so 0.6026 minus 0.6000, and that is going to give us 0.0026. So this is definitely smaller. The 13 is smaller than the 26. So we're going to use z equal to 0.25, and this is going to be a negative. I'm sorry, I forgot to drop that negative, because remember, it's going to be, since it's 60%, the highest 60%, then it's lower than my mean, which would make me a negative value there. Okay, so which score represents the lowest 30%? So the lowest 30% on this. So again, we're looking at below the mean because we're looking at smaller than 30%. So we're going to use this guy right here, and we're going to look in the C column because we're looking for lower. So we're going to look here, and looks like it's going to be one of these two. So again, we're going to do our subtraction. Remember that 30% is 0.3000. So we're going to have 0.3015 minus 0.3000. That's going to give us 0.0015. And then we're going to do 0.3000 minus 0.2981. And when we do that subtraction, 0.3 minus 0.2981, we're going to get 0.0019. 15 is smaller than 19, so we are going to use this guy right here. And since it's going to be smaller than we're looking for the lower 30%, this is going to be z equal to a negative 0.52. And that would be our answer for 8C. And then for our last one, we're doing the lowest 80%. But think about that again. The lowest 80%, that's going to be bigger than 50%. So what I'm going to be doing is this one right here. I'm wanting the column B. My z-score is going to be a positive. I think I want 80% of my data lower than that. So that's going to be between one of these two scores here. So if we do 0.8000 minus 0.7995, we're going to get 0.0005. If we do 0.8023 minus 0.8000, this is going to be 0.0023. This one is 5 is definitely smaller than 23, so we're going to use this guy. Again, my z-score is going to be above my mean, so my z is equal to 0.84. For the z-score, as far as reading the charts, I think those are probably the hardest ones where you're having to go backwards, because you need to figure out, is your z going to be above your mean or below your mean? And I want you to really think about where it's doing with, like it says, the lowest 80%. So that means you want 80% of your data to be below that. Well, if the mean is always going to be 50% of my data below, then 80% would be to the right of that. So you just kind of have to really think about that. And remember, again, whenever you're looking at that chart, here at the center, that 0 value, that is 50% below, and that is 50% above. So then you kind of have to think, if I want below 80, then that's got to be over here. If I want this to be below 80, then it's got to be over there on that side of the equation, or outside of the mean, which means my z-score is positive, and you kind of figure out which one you need to use for that. And the only time you should be using that last column is when you have the two z-scores you want to look between. All right, question number 9. We're going to do so we're going to use the percentile ranks here. And I didn't show you the chart on this one. I'm not sure quite why I didn't do that, but I'm just going to tell you how to go about doing this. So for this first one, I'm going to find our z-score here. I'm going to do 75 minus 80 divided by 12. When we do that math here, that's going to be negative 5 divided by 12, which is going to give us negative 0.42. Again, what we're going to do is on our z-score chart, we're going to look that up. We're going to look at, so let me show you here really quick. So here's my 0, here's my negative 0.42, and I want to be lower, so I am going to look at my column C, because that is my tail of my negative distribution. And when you look that up, you would get 33.72%. Do the same thing with this guy. So Z is equal to 100 minus 80 over 12. So that's going to be 20 divided by 12, which ends up being 1.67. So on this one, so this was for problem number A. For problem number B here, think about your chart. Again, here's my 0. 1.67 is here. And I want the data below, since I'm talking about percentile ranks. So I would want to look at column B here for this one. Column B is my body, or the biggest part of mine. And when you find that, you would get that 95.25% of the data is below x equal to 100. Okay, now for the 11th percentile, what we're going to look for is we're going to look for 0.11 on the inside of our chart. We want to find the z-score. The z-score that corresponds with that is a negative 1.23. So I'm going to come down here for C here. That means that we're going to do x equals our mu plus our standard deviation times z. So this is going to be x equal to 80 plus 12 times a negative 1.23. So that is going to be 80 minus 12 times 1 minus 14.76, and 80 minus 14.76 is equal to 65.24. There we go. Doing the same thing with the 98th percentile. This time we're looking for 0.98 on the inside, just like we were doing on question number 8. So here the z-score that corresponds with that percentage or that percentile is a z-score of 2.05. So we're going to do the same thing we just did for that one. So for D, this is going to be x equal to 80 plus 12 times 2.05. So this is going to be 80 plus 24.60, which would end up being 104.60. So this would be my answer for D. Now for the last one here, notice it's giving me my Q1 and my Q3 z-scores. So for Q1, to do the same thing we just did for E and D, or I mean for C and D. So we're going to do 80 plus 12 times a negative 0.67. So 12 times negative 0.67. So this is going to be 80 minus 8.04. Okay, so 80 minus 8.04 is going to give us 71.96. So there's my answer there. I'm going to do the same thing for Q3, except it's going to be a positive 0.67. So 80 plus 12 times 0.67. So this is going to be 80 plus 8.04. So this will be 88.04. There's my Q3. And remember, for my interquartile range, that's that IQR, I subtract Q3 minus Q1. So for IQR, we do 88.04 minus 71.96. And that is going to give us 88.04 minus 71.96, 16.08. Okay. So I know I didn't show you how to look up the values on that. You might want to go back to this problem and practice it on your own, trying to look up those percentile ranks and seeing if you can get those same percentages and answers. Oh, I did have it broken down. I'm so sorry. I completely lied about that. I am gonna go on to question 10, since we've already gone through those particular problems. Sorry about that. I didn't realize I had broken them up. It says a sample of n equal to 4 scores with m equal to 43 is selected from a population with a mean of 40 and a standard deviation of 8. What is the expected value of the sample mean? Guys, when we talk about expected value of the sample mean, we expect that the sample mean will be the same as the mean of the group. So our expected mean would be 43. Okay, our sample mean and our expected mean, our expected value for the sample mean should be the exact same value. Okay, a researcher develops a new exercise regimen for influencing muscle strength. The researcher knows that scores on a well-validated measure of muscle strength are normally distributed with a mean of 15 and a standard deviation of 4. The researcher administers this new exercise regime to 64 adults who subsequently score a mean of 16.5 on the measure of muscle strength. What is the conclusion based on these results? Okay, so since we are doing a sample, we're going to not use our basic z-score. We're going to use the one where we do the mean. This is the sample mean z-score. So mean minus the mean of the sample minus the population divided by the standard error. Okay, and remember, standard error is just your standard deviation divided by the square root of your sample. So in this case, our standard deviation is 4 divided by the square root of 64. So this is 4 divided by 8, or 0.5. Anytime we start to talk about how many people we had in a sample, and instead of giving you a single score, we give you the score of a sample, then you're going to start using this guy with our standard error instead of just the standard deviation in the denominator. So now when we find our z-score, we have 16.5 minus 15 divided by our standard error of 0.5. So this is going to be 1.5 divided by 0.5, which is going to be 3. So our z-score is 3, and that is very substantial as far as being significant. Because remember, when we think about our z-scores and our percentages, again, just because I'm doing this for a mean doesn't change it. So if I have from 1 to 1 here, that's 67%. And if I go from 2 to negative 2, this right here, that's 95%. Well, when you go from negative 3 to positive 3, this whole thing is 99.9% of your data. So that means that if you're scoring at a z-score of 3, you're way out there on your measurement. Okay, if you're going beyond 3, that means you're only looking at 0.1% of the population scoring that high. That's significantly different. So let's go look at our options. So it says the new exercise regime has an effect on muscle strength because the computed z-score does not reach the threshold of 1.96. Well, this is not true right here. It does reach that. So that is not our answer there. The new exercise regime does not have an effect. Well, it does have an effect. We had a big old z-score, so we know that's not. The new exercise regime does not have an effect. Well, we know that's not true as well. The new exercise regime has an effect on muscle strength because the computed z-score reaches this plus or minus 1.96. And what it means here is that your 1.96 is less than your z-score of 3.00, which is completely true. That is why we're saying it has an effect. So our answer here would be D. All right, last question. It says for a normal distribution with a mean of 100 and a standard deviation of 20, find each of the following proportions. And really, we're just going to do the very last one. Everybody else, I think, for the A, B, and C had those right. This was the only one where we were kind of struggling on. So what we're going to do is find the z-score for 91. So we're going to do 91 minus 100 divided by 20. So this is negative 9 divided by 20, which is going to be negative 0.45. And then we're going to find the z-score for the 102. So we're going to do 102 minus 100 divided by 20. So this is 2 over 20, or 0.1. Now, unlike the previous ones we did, notice that these are not the exact same z-scores. They're different. So we can't just double that last column like we were doing. So what we're going to have to do is we're going to have to we're still going to use the last column, and we're going to use the last column here, but what we're going to do is add those two proportions together. So for the 0.45, we get this 1.736. So we're going to take the 0.1736, and then we're going to come over here to our other one, and we're going to add the proportion from the mean to it, which is going to be 0.0398. And when we add those two values together, we get 0.2134, and this would be our answer. So when the values come out to be the same value for the z-scores, when you're talking about a between area, you just have to look up the one z-score and double it. But when they're different, like this one is, you have to look up each individual proportion from the mean to that, and you just take those two values and you add them together. If there's anything from exam 3 that you would like to see in addition to these problems, just email me and let me know, and I will create another video for you guys.